சொன்னால
ஆஸ்திரேலியால அவங்க எப்படி இருக்காங்க? ஆன்டிக்கு வந்து அந்த அளவுக்கு ரொம்ப நாலேஜ் கிடையாது. தமிழ் மேல படிக்கணும் அந்த நாலேஜே கிடையாது.
Climate change refers to long-term shifts in temperature and weather patterns. These shifts may be natural, such as the astral variation in solar cycle.
ஆப்கானிஸ்தான்ல நிலநடுக்கம் காரம் 100 சில்லுன்னு போட்டாங்க. 950 பேர் இறந்து போயிட்டாங்கன்னு சொல்லுவாங்க. ஆப்கானிஸ்தான் போயிட்டாங்க.
Good evening, students. Are you able to hear me? Yes or no?
Yes, sir.
Yes, sir.
Okay. So in yesterday's class, we were discussing some important points, right? So I was telling you about different kinds of magnetic properties of a material. I hope we went through them, right? So just to recollect, let's discuss those points. So what were the concepts that we discussed yesterday? One is magnetizing field. Second is magnetic induction. Third is magnetizing field intensity. Fourth is intensity of magnetization. Fifth is magnetic permeability. Sixth is relative permeability. And I think that was the last concept with which we stopped. Right? Now, the next concept that we are going to discuss today is magnetic susceptibility. Okay, so write down this point as magnetic susceptibility, and it is represented by the symbol chi m. Okay, so basically, if you see what is magnetic susceptibility, right? Susceptibility means vulnerability, means the extent to which a material can get magnetized in the presence of external magnetic field. Or if I have to put it more in a refined way, even if I apply small value of magnetic field, will it respond to it and get highly magnetized? So if something like that happens, right, then you say that the magnetic susceptibility of that material is high. Okay. So if you read the definition, it says magnetic susceptibility is the measure of the ability of substance to take up magnetization. Okay, it is the ability of a substance to take up magnetization when it is placed in a magnetic field. Okay, now how do you define it as? So if you define susceptibility, it is defined as the ratio of intensity of magnetization to the magnetizing field intensity. Okay, so this is how it is defined, and the most important point to note here is it is a dimensionless quantity. Okay, it is a dimensionless quantity. It doesn't have any unit because the unit of magnetization and the intensity of magnetization, magnetizing field intensity are the same. Okay. And the last point that we are going to discuss is what is the relation between magnetic permeability and magnetic susceptibility. This is a very, very, very important relation. Okay. For which we are going to start the derivation from magnetic induction. So magnetic induction, we know it is written as mu naught into H plus M. Okay. But we know that mu is equal to B by H. This is an important expression, remember, okay? So mu is equal to B divided by H. That implies B is equal to mu into H, right? So if I take this value and substitute it in the space, mu H will be equal to mu naught into H plus M. Or if I take that H outside, then it becomes mu naught H into 1 plus M divided by H. So this H and this H will get cancelled. Then we can write mu n is equal to mu naught into 1 plus M divided by H can be called as chi M, which is magnetic susceptibility. Or from here I can write mu divided by mu naught is equal to 1 plus im. Then this mu divided by mu naught is what is called as mu r, which is 1 plus chi into m. So this is the relation. So magnetic permeability, relative magnetic permeability relative magnetic permeability is equal to 1 plus magnetic susceptibility. As I told you, this is a very, very, very important expression to remember. Okay. Let me know once you're done writing it. Let me know once you're done. Is it done?
Yes, sir.
So you call this as relative magnetic permeability. Okay. Now, I'll show you a video. Yes. So now I'm going to explain you a table. Okay. I'll show you what table I'm going to explain. We are going to discuss about this table where we talk about different kinds of magnetic materials. So if you see till now what we did is we saw what are the properties associated with magnetic materials. Means these are all the terms that are needed for you to talk about magnetizing a material or the created magnetism to exist for a material. Now what we will discuss is how are the elements classified or how are the magnets classified depending on how they respond to external magnetic field. Okay, for that I'm going to show you a video. Observe. So concentrate. So the three types of magnetism is what we are going to discuss. See, for example, you're able to see different elements present there, right? Water, bismuth, and all other things. If suppose water is there, what do you think will happen when the magnet is taken closer to water? What do you think will happen? Attract, repel, nothing will happen. At least guess. Attract. Okay, one guess. Others?
Attracts.
Okay. Let's see what is going to happen. What did it do? Did it get attracted?
It got repelled, sir.
Yes. So it started repelling. There is a reason for it. Okay. Similarly, so you have different materials, right? Graphite, aluminum, you have glass here. Now we'll see how do these materials respond to the external magnetic field. Okay. See them.
This is a new and different category of magnetism called either para or diamagnetism, different from the magnetism that you're used to.
See, we generally get the magnetism that we generally see is ferromagnetism. What do we generally do? You take a magnet and take it closer to a steel rod. See, for example, you have a bolt for a door. When you place it, when you take it close, when you take the magnet close to the door, the steel part, it starts getting attracted. Correct? So that kind of magnetism is called as ferromagnetism, where iron is involved. Where iron and magnetism is involved is what we call it as ferromagnetism. But there are two other important magnetism also that we need to discuss. One is called as paramagnetism and the second is called as diamagnetism. If you observe, paramagnetism and ferromagnetism are somewhat similar, except the fact that one is stronger and one is weak. First, we will see an example of how ferromagnetism will exist. So you're able to see an iron nail here, right? Right? So if you take that iron nail and you're able to see some pins on top of it, if you take that iron nail close to that pin, do you think that the iron nail will be able to attract those pins? Do you think that will happen? No. So it is not going to happen because the iron nail as a whole doesn't have any magnetism of its own. Right? Now see.
Pretty familiar with ferromagnetism.
See, nothing is happening.
An unmagnetized
Whereas if you take that iron nail and connect it to a magnet, okay, you connect it to a magnet, see what is going to happen now.
becomes a magnet in the presence of
So it is getting attracted. So the iron nail, which was initially not exhibiting any magnetic properties, now started exhibiting. Why did it happen? Because magnetic field is induced in that iron nail. So the iron nail is there, right? There is some magnetic field induced in it because of the external magnetic field. The red color magnet is there. No, it will have a field around it. And when this nail is placed in the field of the external magnet, it starts acquiring some magnetic property and it is able to exhibit this kind of a phenomenon. Now, the most important part is,
magnetic field. The effect is strong.
so now the important part is what will happen if the nail is disconnected from the magnet.
That's even after the
See?
magnet is removed.
What is happening? It is able to still exhibit magnetism because the induced magnetic field in that nail is getting retained. And this property of ferromagnetic substances is called as retentivity. Okay.
Paramagnetism.
Now, if you talk about paramagnetism, paramagnetism is exactly similar as that of ferromagnetism, except the fact that paramagnetism is weaker magnetism. Okay, whereas ferromagnetism is a very strong magnetism.
Is a similar effect, except that it's much weaker and temporary. Aluminum.
So if you take aluminum, okay, and if this magnet is taken closer, see how it responds.
It's a good example of a paramagnet.
So it is getting attracted. So in the previous case, when you took it close to water, you observed that water repelled the magnetic field. Those kind of materials are called as diamagnetic materials. Whereas the materials which respond to magnetic field and get attracted are called as paramagnetic or ferromagnetic. But if the attraction is weaker, you call it as paramagnetic. If the attraction is stronger, you call it as ferromagnetic. Okay.
Sir?
Tell me.
Sir, but when we rub a cone in our hair and bring it near to the water,
That is electrostatics. That is electric charge. Here it is about magnetism. There you're talking about static charges. Here you're talking about charges in motion. Charges in motion only can produce magnetism. I told this many times. Correct? Is it
Yes,
right?
sir. Yes, sir.
Yes. So don't get confused between both.
And so does
Similarly, you have liquid oxygen. This is called as liquid oxygen. See how it responds to magnetism.
which is attracted to magnets. Here, I have a few millimeters of
So you're able to see the liquid drops falling on it.
sticks to the magnet. I'll explain why later.
Okay. So this oxide, see what is going to happen to it.
Oxide
It gets attracted.
are good examples of paramagnetic substances.
So these are all the examples of paramagnetic substances. On a counterpart, what will a diamagnetic substance do? Diamagnetic substance will repel the magnetism. Okay, repel the external magnetic field.
Liquid sulfate is a salt that can be picked up by a magnet.
So now we are going to see what is the difference due to which, or what is the differentiating factor between a paramagnetic and a diamagnetic substance. Can someone guess? So the paramagnetic substance that you saw was aluminum. The diamagnetic substance that you saw will take water itself. Okay, it has something to do with the atomic structure of these elements due to which the property is exhibited. Any idea? Any idea? So I'll give you a hint. What is the valence? What is the atomic number of aluminum?
13.
13. So can you give me the electronic configuration of it? 2, 8, and 3. Correct? So 2,
Yes, sir.
first shell 2, second shell 3. 8. It completes an octet, and the third shell has 3 electrons. So when you talk about those 3 electrons, can I say 2 electrons are paired in the s orbital, and 1 electron is unpaired in the p orbital?
Yes, sir.
Yes. So paramagnetism occurs due to the unpaired electron that is present for that particular element. Whereas if you see water, right, when you write water, what will happen? On oxygen, right? So what kind of a bond does water form? Ionic or covalent?
Covalent, sir.
Yes, because it shares the electrons. No, hydrogen has 2 electrons. It is going to share it with the oxygen. So oxygen will share 1 electron on this side and the other electron on this side. So how many more electrons are left out with oxygen? Oxygen, the atomic number is 16. 2, 8, and 6, out of which 2 electrons are already paired. The remaining 4 electrons, will they not form 2 lone pairs? Means they are paired. Means they are paired in the sense they are exactly opposite of what paramagnetic materials are exhibiting. So in paramagnetic materials, you have an unpaired electron, whereas in a diamagnetic substance materials, you see that all the electrons are paired. Is it clear? And it is due to this reason only paramagnetism is exhibited by those materials and the diamagnetism is exhibited by materials where pairing of electron takes place. So it is the same thing that he is going to explain. See.
Diamagnetic materials are exactly the opposite of paramagnetic. They are always repulsed. They would rather die than be in a magnetic field. An important example of a diamagnetic material is graphite. This specially made pyrolytic graphite is repelled by a magnetic field. Don't be confused. This is not static electricity or eddy currents. Graphite is repelled by a magnet, always, both by the north and south end. Pyrolytic graphite is a grown crystal of flat carbon layers, which maximizes the diamagnetic effect. Of course, the best diamagnets are super.
So these are superconductors. See what will happen.
Which at low temperatures provide exact opposite repulsion to whatever magnet.
Any idea about what this technique is called as? You are able to see the magnet is floating, right? Any idea about what this technique is called as? It's called magnetic levitation or maglev. Have you heard of this word, levitation? Means they will float. There are trains also which are designed on this concept. The bullet trains mainly work on this concept only. That's why they have that speed, because they don't experience friction.
Its presence when in chill. They are perfect diamagnets.
Yes.
Most famous and powerful diamagnetic is bismuth, element number 83 on the periodic table. The The dissonant power boat sails toward the weaker magnetic fields.
So these are all diamagnetic substances, okay? Whichever repelled.
One way to check whether an object is diamagnetic or paramagnetic is to see how it aligns itself in a magnetic.
So this is another way of testing. So this is a part of your exam also, syllabus also. So observe, if I have a north pole and a south pole here, right? If we have a north and a south pole here, and there is a material that is suspended like this with the help of a thread, right? So when you suspend a material freely, and if that material aligns in the direction of magnetic field, I repeat it, if the material aligns itself in the direction of magnetic field, it will mostly be paramagnetic or ferromagnetic substance. I repeat it, when you suspend a material freely in the air, and if it gets aligned in the direction of magnetic field, in the direction of external magnetic field, then that material is either a paramagnetic substance or a ferromagnetic substance. Whereas, if the material aligns itself perpendicular to the magnetic field, whereas the material aligns itself perpendicular to the magnetic field, then it is called as diamagnetic substance. So why I'm saying perpendicular is because it will align itself in the direction of weaker magnetic field. So in the direction of magnetic field is in the direction of stronger magnetic field. In the direction perpendicular to magnetic field will be in the direction of weaker magnetic field. Now you see, you can observe that also.
Diamagnetic objects like glass will rotate to avoid magnets. Here,
So see, there is a glass which is suspended and a strong magnetic field is created. Now look at the way it will turn, no?
see that the glass is diamagnetic. Twist to get
Did you understand? So the glass will try to align itself in the direction of weaker magnetic field, that is in the direction of equatorial axis. Okay. And observe, it is happening very slowly. It is not like instantly it is happening. It will happen slowly. Whereas in the other case, if you use aluminum,
but aluminum rotates into the field, typical of a paramagnet.
so you're able to see, the aluminum was initially kept in the direction perpendicular, but it started aligning itself in the direction of magnetic field. So this is what is exhibited by paramagnetic and ferromagnetic. But as I told you, when you talk about a paramagnetic material, it will turn slowly. Ferromagnetic substance will turn quickly.
On the periodic table, we see that aluminum has 3 valence
So this is what I already explained, you know.
paramagnet. We see from the periodic table that aluminum has 3 valence electrons. That's 2s
So 2s and 1p.
paired electron. That is 3. Yes.
Okay, when you talk about water,
It has all its electrons.
it has lone pair of electrons, and that is the reason why it exhibits diamagnetism. So to put it in simple terms, wherever you have unpaired electron, it exhibits paramagnetism. Wherever you have paired electrons, that material exhibits diamagnetic. It exhibits diamagnetism. That's as simple as that. Is that clear?
Yes, sir.
So based on this, what we are going to do is, we will discuss this table. So when you talk about the effect of magnets, right? Now see, observe this clearly. You have already seen the experiment. Now you yourself can answer how those materials will respond. Okay. Listen. First, effect of magnets means when you bring an external magnet, How will a diamagnetic substance respond to that external magnet? Will it attract or repel?
Repel.
Repel. And is it happening slow or faster? Is it a strong process or a feeble process? It is feeble.
Slow.
So diamagnetic materials feebly repel are feebly repelled by the magnets. Whereas when you talk about a paramagnetic substance, they are feebly attracted by the magnets. Whereas when you talk about ferromagnetic substances, they are strongly attracted by the magnets. Second, in the presence of external magnetic field, what will happen is diamagnetic materials, yes, they will acquire magnetism, but in the direction opposite to the external magnetic field. Whereas a paramagnetic substance will also acquire magnetism, but it is not going to be strong. It will acquire feeble magnetization, but this will happen in the direction of magnetizing field. So whose magnitude is greater? Ferromagnetic or obviously ferro, because ferromagnetism is the strongest. Okay. So that is why if you see for paramagnetic and diamagnetic, we always use the word feeble, whereas ferromagnetism is stronger. You have the materials here, no, ferromagnetic materials, right? So I repeat, in external magnetic field, what will happen is diamagnetic materials will acquire feeble magnetization, but in the direction opposite to the magnetizing field, whereas paramagnetic substance will acquire feeble magnetization in the direction of magnetizing field. Okay. Whereas ferromagnetic substance will also acquire magnetization, but it will be a strong magnetization, and this will also occur in the direction of magnetizing field. Okay. Now, if you take the same diamagnetic substance and place it in a non-uniform magnetic field, when you place them in a non-uniform magnetic field, they tend to move slowly from stronger to weaker magnetic parts. That's what happened to glass. If you remember, when the glass was initially kept between the north and the south pole, it started moving in the direction perpendicular, and it happened slowly. That is what they're saying. So diamagnetic substances will tend to move slowly from stronger to weaker magnetic parts of the field. Whereas when you talk about a paramagnetic substance, they tend to move slowly from weaker to stronger. Means if you place a paramagnetic substance, if this is North Pole, South Pole, if you place a paramagnetic substance like this, then it starts turning towards the direction of magnetic field. Whereas when you talk about ferromagnetic substance, if you place it like this, no, it will instantly turn like this. Whereas paramagnetic, it will take some time and it will turn slowly like this. Okay. Similarly, if you place a diamagnetic substance in the presence of uniform magnetic field, then what will happen is a freely suspended diamagnetic rod aligns itself perpendicular to the field. Why perpendicular to the field? Because perpendicular to the field is the direction of weaker magnetic field. Perpendicular to the direction is the weaker magnetic field. Whereas when you talk about a freely suspended paramagnetic rod, it aligns itself in the direction parallel to the field. Okay. And the same is the case with respect to ferromagnetic substance also. So these 4 points are related to how these substances respond to external magnetic field. Is there any doubt till here?
Sir, what is the difference between non-uniform and uniform magnetic field?
Non-uniform, what will happen is, see, this is what a non-uniform field is. Right. You have something like this. Then for a non-uniform field, you cannot say perpendicular direction is the exact direction of weaker magnetic field. Whereas when you have uniform magnetic field, right? Okay. If suppose I call this as axial direction, then I can say this will be the perpendicular to it. I will be able to exactly define the perpendicular and say that the diamagnetic material will align itself perpendicular to the external magnetic field. Whereas if you read the statement for both, no, when you talk about non-uniform, they are only saying it gets aligned from stronger to weaker fields. That weaker field can exist anywhere. If you observe,
Okay.
if you observe the glass example also, it didn't stop exactly perpendicular. It was slightly oscillating like this because it was experiencing some torque. It was slightly oscillating. Whereas if you're able to exactly produce uniform electric field, means if you place it like this, it will go and stand perpendicular exactly to the magnetic field. That is the meaning. Okay.
Okay, sir.
Yes. So these are the 4 points. So 4 important points of how these materials will respond to the external magnetic field, whether they are uniform or non-uniform. The next question is, how will the susceptibility, means how vulnerable will a material, vulnerable in the sense, how easily a material can get magnetized is what the question is. When you talk about a diamagnetic substance, susceptibility of a diamagnetic substance is generally negative. Okay, it is between -1 to 0. It's a small value though. So how, if I have to speak in exam point of view, how they will ask is, susceptibility of a material is -0.5. What kind of a substance is it? The answer will be, it's a diamagnetic substance. Okay. Suppose the susceptibility is positive and it is a small value, then it will be paramagnetic substance. Whereas if the susceptibility is greater than 1000, so what do I mean by this is, even if you talk about a ferromagnetic substance, even in the presence of weaker magnetic field, this will be able to acquire more magnetism. It is that vulnerable, means ferromagnetic substances will always be ready to acquire magnetism. Whereas diamagnetic substance is never ready. That is why it has a negative susceptibility. Paramagnetic says, yeah, I'm okay, but only to a small extent. Okay. Similarly, if you talk about relative permeability, then the relative permeability for a diamagnetic substance lies somewhere between 0 to 1. Whereas for a paramagnetic substance lies somewhere between 1 to a very small value. Whereas for a ferromagnetic substance, the relative permeability is greater than 1000. For this one, everything is high only, ferromagnetic substance. Next is permeability value. So what do I mean by permeability value? The permeability of a diamagnetic substance is lesser than the permeability of free space. The permeability of paramagnetic substance is greater than the permeability of free space. The permeability of ferromagnetic substance is very much greater than the permeability of free space. Means if free space is able to allow the magnetism to penetrate through it, ferromagnetic substances will be even more ready to do that. Okay. Next is effect of temperature. That is, if I take a diamagnetic material and I try to magnetize this material along with the rise in temperature, then what we can say is susceptibility of a diamagnetic substance is independent of temperature. Whatever temperature you maintain, it will say, I am not going to respond to magnetic field. Whereas susceptibility of a paramagnetic substance is inversely proportional to temperature. Means if you keep increasing the temperature of a paramagnetic substance, lesser will be the property it will show to get magnetized. In a similar way, if you talk about the susceptibility of a ferromagnetic substance, susceptibility decreases with temperature, but in a complex manner, where the susceptibility is inversely proportional to T minus Tc, where Tc is called as Curie's temperature. So Curie apostrophe S. So what this Curie's temperature represents is, it is exactly the temperature at which a ferromagnetic substance will lose all its magnetic properties. So I would have told you one important point. If you have a magnet and you want that magnet to get demagnetized, one of the ways is by raising the temperature of that material. Okay. Next is removal of magnetizing field. Means you place a diamagnetic substance in the presence of magnetic field, it will align itself in weaker magnetic field. But as soon as you remove the magnetic field, what will happen is diamagnetic materials will be ready to lose their magnetic property attained. Similar is the case with respect to paramagnetic substance also. Whereas ferromagnetic materials can retain magnetism. You saw in that first example, no, when that nail was touched with a magnet and it was taken closer to pins, even when the external magnet was removed, you saw that the pins got stuck to that ferromagnetic material because that material can retain magnetism. Okay. Value of variation of M and H, I'll explain it later. Hysteresis effect, I'll explain it later. And the last 2 points that we will see is physical state of material. So when you talk about a diamagnetic substance, the physical property can be either, it can either be in a solid state, liquid state, or gaseous state. Same is the case with paramagnetic also, whereas the ferromagnetic substances are generally solid state. Okay. Similarly, if you see the examples of diamagnetic substance, bismuth, copper, lead, silicon, nitrogen, water, NaCl, all these are diamagnetic materials. Whereas on the other hand, aluminum, sodium, calcium, oxygen, CuCl2, all are diamagnetic materials. Whereas when you talk about iron, nickel, cobalt, Fe2O3 and alnico, alnico stands for aluminum, nickel, cobalt. These are all ferromagnetic materials. So I'm assuming it is clear till what we discussed. I showed you all the experimental part and explained you how the table is actually formed. Is that clear?
Sir,
Yeah, tell me.
so you mentioned that with increase in temperature, magnetism will decrease or something like that. Why is it so?
Yes. Because the particles are disturbed. No. See, the magnetism itself is exhibited because of something called as dipoles that are generated. The dipole moments are there. No. So it is. See, you remember this dielectric. Inside a dielectric, you have small dipoles formed, right? In a similar way, what will happen is even inside a magnet, when you place it in external magnetic field, there will be a dipole moment that is developed, right? When you try to heat the material, what you're trying to do is you're trying to increase the distance between the poles of the dipole. As a result of which, what will happen? The magnetic dipole moment will decrease. Correct?
Yes, sir. Yes.
That's what is happening. Yes.
Okay, sir.
Yeah. So, apart from that, any other doubt? So this table is important. Okay. Yeah. So this is all about paramagnetic, diamagnetic, and ferromagnetic materials, along with the magnetic properties of materials. Those 8 points, along with this table, is important for you to remember. And secondly, the hysteresis effect is there, right? This hysteresis effect I need to explain for 15-20 minutes, which I will do it in the next class. So in the next class, we'll be completing hysteresis effect and the last concept of this chapter, that is Earth's magnetism. So with that, this chapter is also over. So I wanted to announce one important point. Wait for a minute. Don't leave. So I'm sharing yes. So if you all look at the WhatsApp group, the 12th physics batch, I have shared a schedule. Okay. And the schedule consists of when all you will have physics test of the chapters that are completed: electrostatic potential and capacitance, current electricity, and magnetic effects of current. If you open your mobile, you can have a look at it. I've given all the dates, day, timing, total mark, and I've given a note also stating that in second chapter, there is no deleted portion. In the third chapter, you have potentiometer, which is deleted, and in the fourth chapter, cyclotron is deleted. So once we complete these tests, then I'll give you the schedule for fifth and sixth as well. So by that time, I'll be completing sixth chapter also. I have already sent it. Bhagwat Kumar, I have already sent it in the group. I'm reading from there only. You can check. So there is a small schedule like this that I've shared. Okay. So the schedule is there. And secondly, what I wanted to mention is, I'll be giving you assignments also for each chapter a week ahead at least. So I want you all to work on that and ensure your doubts are clarified and work accordingly. And the third point is study materials have reached. You'll maximum get it by Friday. Okay, we need to consolidate it. Tomorrow we'll consolidate everything. And we'll send an official announcement in the group. You can come and collect the study materials also. That will be helping you for these upcoming tests. Is that clear?
Yes, sir.
Yes, sir.
Yes. Good. Okay. So that's it from my side. We'll wind up.
Thank you, sir.
Yeah.
Sir, the retentivity phenomenon you told about,
Retentivity?
the property you told about the iron nail, so that's a temporary effect, right?
That's temporary only. That's
Okay.
temporary only, but the retentivity, why we use the word is because it will be exhibited at least for some amount of time. Not like it is going to be there even if you come after 10 days. No, that will not
Okay.
happen.
Okay,
Yeah.
sir.
Yes.
Thank you, sir.
Yeah. Okay.
Thank you, sir.